All right, this is SpringBoard, Algebra 1, right? Key features of graphs, interpreting graphs of the function. We will talk about how to relate the domain and range of a function to its graph and identify and interpret key features of the graph. So this is going to be a very definition-heavy introduction of lesson, okay? So you're going to make sure you want to take your notes, write down, again, what, kind of what I tell you versus the definitions that they give. And so that way you can have a realistic understanding of definitions. Okay. Because as long as you understand the definitions, then you can really understand what we're doing here. And this all really makes sense. So, talking about roller coasters. Roller coasters can be scary and fun to ride. Below is a graph of the height reached by the cars of the Thunderball roller coaster over its first 1,250 feet of track. The graph displays a function because each input has exactly one output, and you can see this visually by using the vertical line test. Okay, so vertical line test. Let's talk about your vertical line test. All right. Your vertical line test is that you have an ID badge, right? Your ID badge is always your best friend when you're doing testing because it's a straight edge, okay? It's one of those things that you pop the ID badge off of your lanyard and you use it during your test, okay? But you also can use it for the vertical line test. You take your ID badge, right? And you essentially will naturally have a horizontal line. That line there is not perfectly horizontal. There it is. All right. And you can take that and you can move it from left to right. And at any point in time, does the graph touch it more than once? The answer is no. And so it's a function. If it's going to touch more than once, it's going to be obvious, right? You're going to have a graph. You're going to have a graph, something like this, right? And the graph is going to be something like this, where it obviously touches, right? This obviously touches more than once. It touches, well, if that would go away, right? It touches here and it touches here, right? That's not a function. All right. That's just some examples for you to have there. Let me erase all that. All right. So that's the vertical line test. It says, so we have our graph here. Let's go ahead and let's just evaluate this graph and let's just write down what we know. That's how math works, right? That's how we get really good at math, is that we don't look for the answers like we do in reading. In reading, you read the question, then you go back and try to find it in the paragraph. That's not really what you do in math. In math, you go ahead and take a look at the graph, go ahead and interpret the graph right before you even start. And so that way, when you get to the answers will just kind of then pop out. What are the two lines here that I made? What's this blue line? The x-axis, right? So I'm going to write that this is the x-axis, right? It's always labeled usually as an x for you. What is the red line that I drew? The y-axis, and it's usually already labeled for you. Okay, let's see. Right here where they come together, what do we call this point? Right here where the x and the y-axis come together. We call that the origin, and that is 0, 0. That's where the ordered pair is, 0, 0. Okay? Now, this is representing a roller coaster. I have a point here. I have a point here. I have a point here. All right, there's another point here. And there's a point here. Okay? What does this point right here represent? You're on a roller coaster. What does this point right here represent? Your starting point, right? If you're on a roller coaster, you're usually in line, right? You're in line, and that's your starting point. So this is your starting point. Starting point, right? And what is the ordered pair for your starting point? Remember, ordered pairs, you guys struggle with this. Ordered pairs, right? You have an X value and a Y value. You have an X value and a Y value. So what is the ordered pair for this starting point?
0, 10.
No, 0, 0 is down here. That's the origin.
0, 10.
0, 10. So this is at 0, 10. Okay. And if we have a starting point, what should we have? An endpoint. And that's going to be here, right? We're going to say this is our endpoint. And what's the ordered pair for it? No, it's not.
1,250 to
It's the distance. Look at the x-axis. The x-axis represents the distance along the track.
1,250.
Yeah, if you're at the end of it, that means you've gone the 1,250, but you're back at the starting point. So how high are you off the ground?
10 feet.
10 feet. Your endpoint's not your starting point. Do they let you stay on and ride the roller coaster again? Nope, you got to get off. All right. What about this point here? What do you know? What's special about that point?
That's the climax. I like the highest point.
Highest point, climax, a peak, right? All right, so we'll call that a peak, right? What's this then?
That's 105.
Yeah, but what is that? What's that point represent there?
Another piece.
Yeah, a peak, right? That could still be a peak, right? You ever gone right? So we even say that, hey, look, you can even say this is peak number 1 and this is peak number 2. Well, then what's this?
A valley.
A valley, right? If we're talking about mountains, right? We have peaks and we have valleys. Remember, peaks only occur when it goes up and then back down, right? That's where this one occurs. It goes up and then it goes back down. Valleys occur whenever it goes down and then back up, right? So you can call this a valley, right? You said this peak is the highest, is what you said. You said this peak here is the highest. Well, how high is it?
It is 105 feet.
It's all right. So what's the ordered pair for it?
105.
No, start at your X. So this would be 250,
250, 105.
110.
Oh, 110.
So 250 feet into the ride, you hit the maximum at 110 feet. And what about the valley? What's the valley here? Ooh, well, let's see how that's counting, right? So you have 250, 1, 2, 3, 4, 5, and then it goes to 500. What's the difference between 500 and 250?
250.
250. So what is 250 divided by 5?
50.
50.
Yeah, 50.
So these are in increments of 50. So this would be 275, right? 275, 300, right? So that's how you can get that. So here, 500, and then, so what's this?
550.
550. The valley here is at 550. And how low is it?
30.
30? Okay. What about this peak here? This peak is at, yep, 800. And how high is it?
90.
90, right? Use your ID badge, right? Remember how I said you use your ID badge? Use your ID badge and make sure it's straight, and you can clearly see, right, that goes to 90. All right. Nothing else really for me to kind of identify this. Now, here's the thing. Whenever I do this graph, I'm not writing this stuff down every time, but when I look at the graph, this is what I look at. Okay? This is what I see when I look at the graph. I may not write it down, but this is what I'm noticing. Okay, where does it start? Where does it end? Does it have any peaks? Does it have any valleys? Right? Where does it? All right. I have. Does it cross the x-axis? No. So that means that it never goes. If it crossed the x-axis, what would the roller coaster do? No. Think about it. What does the x-axis represent? Yeah, right, because the x-axis represents the ground. So that means you would have a roller coaster that would go underground. Okay? So that means maybe it's like a tunnel or something, right? And there's roller coasters that do that, right? Where like you dive down and all of a sudden you go into a tunnel. All right? Those happen. What about where it crosses the y-axis? What is that? All right? That's just how high it is at the starting point, right? How tall it is at the starting point. We'll get into y-axis and all that stuff here in just a second. So this says, naturally, if we're doing a function, we have to do the domain and range. This says that the domain gives all values of independent variable, right? Your independent variables. Your independent variable is a variable which input values are substituted for a function. So the independent variable, and I'm going to write this in black, right? The independent variable says that it goes, right? It goes with your domain. It says here that it is your input values, right? It says it is your input values. Well, what variable represents your input values? What variables do you list in your domain? Yeah, your x, right? So what variable is my independent variable? Your x, all right? It's going to be your x, right? So your x variable is your independent variable. Your x variable is your independent variable, okay? I have a list. I have something like that kind of similar up here in my classroom that's listed out, right? That just shows that your domain is your list of inputs, and input is your x variable, which means if it says here that your domain gives all the values of your independent variable, then if your domain is your inputs and your inputs is your x variable, then that means that your independent variables is your x variables, right? It kind of goes and it shows that. But this is going to be something different, okay? And this is something that you need to make sure you write down, that when we have what's called a continuous function, when we have a continuous function, our domain and ranges are different, okay? Our domain and our ranges are different when we have a continuous function, okay? A continuous function is when the graph is a line, right? That definition is on the next page. We'll cover that in a second. What we've been doing up to this point has been points, right? Where we've been listing points. That's called a discrete function, okay? So a continuous function is a line. That means that there's no gaps. So we have to represent that. And here's how. For your domain, which is your independent variable, which is what variable? What? Your x variable, right? So I'm going to put my x in the center. Then I'm going to put what it has here. It has my less than or equal to, right? I have my less than or equal to symbols. And then I put my smallest here, and I put my largest here. My smallest what?
No.
X. What is my smallest X term in the graph, right? What is the smallest horizontally? Horizontally, right? What's the smallest horizontally? I do the same thing for the range, right? Less than or equal to y, less than or equal to. We'll draw my brackets. Okay. And again, this is going to be, well, hey, what is the smallest or what is the minimum, right? What is the largest or what is the maximum? Okay. Getting into those terminologies, right? That this is the minimum. This is the maximum. This is the minimum. This is the maximum. Getting into that terminology. And again, this is going to be vertically. Your range is your y, which is vertically. So you're going to look at this. This is like a cheat sheet of writing domain and range. This is something you're going to look at. You're going to have to commit it to memory. This is something that when you're doing a domain and range of a function of a line, this is how you write it. And if you remember that this is how you write it, it becomes really easy to write domain and range. Because look at my graph. What is, according to the x-axis, what is the leftmost that this graph goes? Here, right? It goes here. This is the leftmost that it goes, right there. And that is at 0. Well, how far to the right does it go? 1250. And because it's a line, it fills in the entire gap from left to right. So that's what I would write here. I would write 0 and 1250. That's how they got this as their domain and their range. Look at it vertically. What is the minimum? How far down? What's the lowest point?
10.
Right here at 10, right? Right there at 10. What's the highest point?
110.
Right there at 110. So that's what I write. The minimum is 0. The maximum is 110. That's where they got this from. Okay, that's where they got that from. That's called your independent and dependent variables, right? We've talked about that stuff similar. Independent and dependent variables. What's depending on the other? Age and height, right? Does your age depend on how tall you are? Or does how tall you are depend on your age?
How tall you are depends on your age.
Yeah, right? You're not 6 foot tall when you're 1 year old. Okay? Everybody's not 6 foot tall when they're 1 year old. Your age dictates your height, okay, in relevance to how tall you are going to be. The amount of things you buy are dependent on the money that you have. How well you do in this class is depending on the effort you put into it. Okay, that's how you kind of understand independent and dependent. So here we go. I'm gonna give you some simplified definitions for every one of these, so that way you can know in your head what they mean. A continuous function. Well, you should already know that. What does a continuous function look like?
A line.
It's a line. Okay? Continuous function is a line. What does a discrete function look like?
Like, not a straight line.
Small. Just random points on the graph.
What does it say?
Individual points.
Points. Right? So continuous looks like this, right? Discrete looks like that. Okay? Continuous and discrete. All right. Continuous, it's hard to make a table because a table won't cover everything. Discrete, I can make a table and describe it perfectly. All right. Y-intercept, where the graph crosses the y-axis, where the graph, right? Where the graph crosses the y-axis. We have two different types of minimums and maximums. We have absolute and we have relative. Absolute maximum is the highest, which means absolute minimum would be the lowest. This right here, quality stuff. Unlike relative minimums and maximums, absolute maximums and absolute minimums may correspond to endpoints of the graph. What does that mean? That means that these, and I'm going to just simply write, can be endpoints. These can be endpoints, okay? Relative maximums and minimums, it says the greatest value for a limited open domain. That is a gap in the graph that makes the peak. That's not included in the endpoint, okay? This one here, because that's a peak, is because I can say, well, this point here and this point here, and there's a peak, right? So my relative maximums means that it's a peak. Minimum means that it would be a valley. But both of these, as it says here where I highlighted, can't be endpoints, right? These can't be endpoints. Ooh. Sorry, writing sideways kind of is jacked up a little bit. But anyway, can't be endpoints, right? These can be endpoints. These can't be endpoints. All right, so here's what we came to do, okay? Because they occur within open interval domains, right? They cannot correspond, right? It says right here, they cannot correspond to the endpoints of the graph. Again, open interval, here is the definition of an open interval, right? An open interval means that it's not, it can't be equal to, right? Means that it's open. That means that it cannot be equal to. It has to be greater than or less. It has to be less than, but not equal to. All right. Here comes the easy peasy questions. We've started this, right? And it's a lot of build up, but now the questions, the answers to the questions should just flow. Okay. So go ahead try 1, 2, 3, 4, and 5. Okay, go ahead and try 1, 2, 3, 4, and 5. All right, those that are watching on the video, pause it. Try 1, 2, 3, 4, and 5. Okay, and then unpause it and check your answers. But with all this build up, 1, 2, 3, 4, and 5 should just flow. All right. Okay, so my class is working. So I am going to type in the answers and let you check and see if what you got is what it is while they're working. Please make sure you write down, it says, what does it represent? Please make sure that you do that. Say what it represents. Just, you're not reinventing the wheel here. Just be literal. What does it stand for? Relative maximum, right? Got 2 of those. All right, let's talk about number 1. Number 1 says, what is the y-intercept of the function shown in the graph, and what does it represent? What is the y-intercept? What is the y-intercept? The y-intercept is where the graph crosses the y-axis. Okay? Remember in math, if you don't know what something is, you need to keep writing the definition until it gets ingrained. Okay? The y-intercept. What is that? It's where the graph crosses the y-axis. Write it until it becomes ingrained in your mind. Okay? Well, where does this graph cross the y-axis? Well, here is the y-axis, this red line. We said that the starting point, which was right here on this graph at 0, 10, well, that's on the y-axis. So the y-intercept is the starting point. They're usually the same thing. The y-intercept and starting point, they're usually the same thing. The y-intercept is usually your initial value. Okay, so where is it? 0, 10. What does it represent? The height of the roller coaster at the starting point. Identify any relative maximums. Relative maximums, those are our peaks. Do we have any peaks? Yeah, we had peaks at what? We had a peak here at 110. We had another peak here at 90. So 110 or 90? No, those are both. We had 2 peaks, right? We had 2 peaks, right? So that means we'll have 2. Identify the absolute maximum of the function, right? Identify the absolute maximum of the function. I don't know why that's popping up. It's weird. Tyler Price, Alexandria Senior High. I don't know. That's kind of weird. I don't know why that's popping up. I don't even know where that would even come from. So anyway, let's see. The identify the absolute maximum of the graph represented by the graph. Well, what is that is the max, right? What is the highest? 110. It's the greatest height of the roller coaster. Identify a relative minimum. Relative minimum is the valley, right? What's the valley? Do we have a valley? Yeah, we do. It's right here at 30, right? It's right there at 30. We have a valley. It's right there at 30. Identify the absolute minimum of the function. All right. What is the minimum? What is the lowest that it goes? 10. Interpret the meaning. It's the lowest that the roller coaster goes. It is the least height of the roller coaster. That is the introduction to lesson activity 6.1, numbers 1 through 10. Watch the next video for, 1 through 5. Watch the next video for 6 through 10.